class. Today we are doing the free radical addition of HBr to alkenes. It is an anti-Markovnikov orientation, although it is very Markovnikov in form. It follows Markovnikov rule. See. This is a peroxide, and peroxide will form two free radical alkoxy radicals, right here, which will react with HBr to form more radical Br, right here, because radicals react to form more radicals. Now that we have the bromine radical will react with this propene, or 1-propene, to form the more stable free radical intermediate. So the bromine will react with this primary carbon because the secondary carbon is more substituted. So it reacts here. Now that we have the more substituted free radical intermediate, because the secondary carbon is more substituted than the primary carbon, it will react with the more HBr in the pot to form 1-bromopropane. Yay!
1-propene is a rather uninteresting example though. Therefore we thought up of several more interesting molecules to work with. For example, this 2-methyl-1-butene molecule. We reacted with our HBr and peroxide again to see what happens. And what happens is the exact same thing that happened last time. The Br radical will react with the less substituted carbon, and the radical will go on to the more substituted carbon, creating the Markovnikov position, the more stable intermediate. The hydrogen from the Br is then going to come in and react with this free radical to form our final product, and after which, of course, termination events occur.
I think it's important to show that free radicals do not rearrange. So when we do anti-Markovnikov orientation, or really, it follows the Markovnikov rule, but anyways, the free radical bromine will react again to form the more stable free radical intermediate right here. And instead of rearranging with carbocations in 1-2 shifts, it's just going to take that hydrogen right next to it, forming the desired molecule.
What do we do about this monstrosity? It looks incredibly complicated. Fortunately, what occurs is exactly what occurred the previous times. We will have a Br radical reacting with our double bond. A radical forming on the more substituted carbon, and our Br going into the less substituted carbon to form the more stable intermediate. To finally form a cyclic structure that is anti-Markovnikov.
Well, you know, at the end of each week, we have a quiz. I know we look forward to these times in our lives, so I wouldn't deprive y'all of having another quiz. Trivia question number 1.
Will HI and HCl also show the peroxide effect?
Yeah!
Minus 2.5. HCl and HI will not exhibit the peroxide effect due to the relative kinetics of the reaction. What will occur when methane reacts with HBr and peroxides?
Yeah.
Minus 2.5. Methane does not exist.
What is your favorite color?
What kind of questions are these?